Now, let's move through. What we're doing is looking at the idea of foundation inspections first. Now, what they're calling, and this is only the workbook, so y'all may use different terminology, and in fact, I think the code probably uses a little different terminology, but they're calling a foundation inspection anything that is dealing with the footing, the foundation wall itself, and a slab on grade. Now, we have the potential for monolithic pours, which would be the footing and the foundation are one kind of a trench element, and then they connect right into a floor slab that's on the ground, supported by the ground. So that would be a monolithic pour condition, which has all three of those elements, but it's all done in one monolithically poured concrete, maybe not at the same time, obviously, but it could be depending on the size and the extent of it. We may be pouring that whole thing at once, but normally it's done in a couple of different stages. And our point here is they've grouped all of those similar type items into what's considered foundation inspections. The rest, from a framing standpoint, deal with what's called rough-in inspection. Now, sometimes it's called close-in. It depends on whether we can have insulation, whether we can put any kind of exterior siding on, those kind of things as to how far it goes. What we're just addressing is structurally. Are we looking at the elements as they're in place before they start getting concealed with interior finishes? So everything that's done once we've gotten our foundation walls up, we start doing floors, and when we do walls and when we do roof construction, and again, multiple floors maybe in a 3-story structure or so, those are all in what's called the rough-in inspection. And then finally, we have what's called final inspections, which pick up this idea of the things which transcend just a rough-in inspection, but also deal with an element in its final form. Let's look at a stair, for example. A stair component, which is typically part of my means of egress in a residential structure, it would be roughed in and my opening would be checked. And then I'm looking at the stair components to see tread riser geometry. Once you've put the actual stairs in, then I'm looking for handrails, I'm looking for headroom, and all of this may happen sometime prior to getting it finalized and turning it over to the actual tenants or owners to be able to occupy. So there are things, and if you think about it, a lot of the stuff in chapter 3, which are driven by the need for final life safety issues, may come up and they wouldn't fall in the footing. They wouldn't fall in, or the foundation rather, they wouldn't fall necessarily in the rough-in inspection. And so it's checking to see that these things are done before we turn it over. And that's the idea of the final inspections. So don't, first off, get hung up too much over the language here. It's only used in the workbook in context of trying to get you to what part of the phase of construction are we talking about. That's the sole purpose of it. You won't find those breakdowns in code itself. The IRC doesn't say, hey, here's the foundation inspections. It will have footings and foundations in the same chapter, which is going to be chapter 4, for example, and it will have concrete slabs on grade in chapter 5 because that's floor construction, and that's what chapter 5 deals with. So it isn't using this same breakdown that we're doing in the workbook. This was what the designer of the course chose as the breakdown, and we've stayed with it throughout the different iterations. I hope that makes sense. But what I wanted to point out was these things are kind of the segments that we're going to be going through, starting with foundations, moving to from footings to the foundation walls, then to the slab on grades. Then we move into this idea of the rough-in inspections. So let's go to the first one. We're going to start with that foundation inspection. As I said, it includes footings, foundations, and this idea of slab on grades. So we start with the footing inspection. Now it'll give you in the beginning a objective, and it's going to tell me how we're going to break this into subtrades. If you were to look in your workbook on page 9, you'd see that it has this overview of the footing inspection. When given, construction documents, you'd be able to determine the compliance ideas as spelled out in the 2018 IRC. Yes.
How can we get an access to the PowerPoint slides?
To the PowerPoint slides?
Yeah, the one you are showing right now.
We don't give out the PowerPoint slides with the program because you've got the workbook. So okay. These are coming from the workbook. There's only a couple of slides that don't.
So there's no way to download them from anywhere?
No, we don't have them available. Not the PowerPoint slides. No.
All right.
Now your download of the book. Have you gotten your download on the workbook?
Yeah, I have the books and everything. I just wanted to know if I can get a copy of the slides as well.
Oh, I'm sorry. No, we don't. Again, they've been in our institutes and our academies. We don't give the PowerPoint slides out. Again, the idea is they are just supported by whatever workbook we're using or documentation we're going through. So.
All right. Thank you.
Sure. Good question. All right. So in the, and this shows up on page 9, you see it's got an objective, then it says the purpose, footing shall comply with the code, and then it gives me code sections. And then it's going to say there are 4 subtasks to a footing inspection. And the 4 subtasks are laid out. It's an environment. So what it's going to do is it's going to look at the environment that your footing is located in. It's going to look at the size and the strength. Now, we haven't poured the footing, so the strength is just going to be what we are expecting when it comes to the actual concrete strength. Then the footing placement, back to frost depth or 12 inches below finished grade, or excuse me, under 12 inches minimum into undisturbed soil. And then we're looking at this idea of continuity, surface, or a step inspection. If my footing is on too much of a slope, if it's on a downhill slope, now when you put the load of the building on it, it's not coming in perpendicular to the actual footing, it's coming in at another angle to the footing, which causes potential for stress cracks, it causes potential sliding of the building, and it may not be huge cracks differentials, but it could lead to a failure of those footings in some fashion or another. So we will call for, if it's more than a 1 in 10 slope, for example, in the code, then it says you need to break that into stepped footings so that it goes across, drops down another footing, drops down another footing, instead of trying to do one that's on a slope, which is more than 1 in 10. And that's the ideas behind the code section. So we've got these 4 broad areas that are going to deal just with footings. So when we look at them, now we'll start with the first one, which was the environment. So it says environment inspection, it's to check your bearing capacity of the soil that is going to be sufficient to hold the building up. Now, once again, you do this at plan review when you check what's expected for the soil type, the profile, where's it's going to be located, versus what my size of my footing is to determine how much of the building it's going to hold up. Now, there are 3 different tables. We'll go through those in a minute. 3 different tables to deal with the footing size. And what we're looking at here is traditionally it's a spread concrete footing. So that means it spreads out to hold the weight coming down of the building, and it's going to be sized based on how much resistance do you get from the soil interacting with that footing. If the soil won't bear the same per square foot weight of the building, then the footing needs to be spread out more until it reaches how much bearing capacity we have available on the soils. Now, with that being said, in some cases, y'all have soil which doesn't get to my minimum to use my tables. And we'll go over that, but the minimum in those tables are 1,500 pounds per square foot. So if my soil bearing capacity doesn't reach or exceed 1,500 pounds per square foot, then I can't use the size of the footings and the engineering that was included in the IRC. In which case now I've got to go and get engineering done. Anytime we ask for engineering, that means we need to bring in who? The engineer or the registered design professional, somebody who is qualified, certified to be able to perform those determinations. So that's the first secret I want to step back to and talk about for the IRC. The IRC was written to be a standalone code, which would include a cookbook approach, more or less, on how you can build a building that is a single family home, a two-family dwelling, or a townhouse. But those structures are going to be limited in height, and it's going to be in height above, if you look at the word, grade plane, which is going to say from grade plane, the stories above grade plane, not the basements, the stories above grade plane can't exceed 3. So no more than 3 stories in height above grade plane. Now the question becomes, what happens when I have a hillside and I cut into it from a part of my basement, but I've got a walkout on that basement on the downhill side, and then it slowly tapers back into ground, and maybe on the far back end, we may be completely underground at that point. Is that a basement or is that a story above grade plane? And the answer is, it depends. So it's going to depend on a couple of different things. And the first thing we have to look at is this idea of where is the grade plane? Now, the grade plane is supposed to represent what's considered the average grade around the building. And so we look at what's expected for that ground surface, which isn't the highest points of ground that we push up against the building. So I got it sloped away from the building on all sides. And we're not going to take up here where it meets against the building. And we're not going to take way down here. We're going to take a point that is within 6 feet horizontally of each wall. And I'm going to look for the lowest points of ground I find within those 6-foot distance. So if it's all straight against the building, then it would be at 6 feet out would be my lowest point. Yet if I have any kind of a swale in here, it may be some point inside of that 6 feet that I get the lowest point. And the more points I take, I'm going to have at least 4 of them, 1 for each side. But the more points I take, because if it slopes downhill and I got this swale, I may take a low point up here and a low point down there. The more points I take, I'm going to average those points to come up with what does that establish as what's considered the grade plane. So that way it's representing what the final grade may end up being after the building is occupied for a while and the ground starts to slowly settle, or they don't keep the mulching up, or again, maybe they've even dug away some of it to where the ground may end up being after some period of time, what we would expect to be the average of ground up against the sides of the building. So that's going to establish this grade plane. From that point, I go to the floor above the floor in question. So the floor in question was the basement. So I'm going to the first floor above that. And that distance from that floor level to where this grade plane is, if it is 6 feet or more, then that lower floor is considered a story above grade plane. And I'd have to count it. Remember, we're limited to 3. So if I had 3 stories plus that basement, which now counted as a story above grade plane, I've got a 4-story above grade plane structure. You're out of the scope of using my engineering for the IRC. And you would have to now treat it as an IBC structure. And some of y'all deal with commercial structures. When we go to the IBC, I'm looking for type of construction, and I'm looking for, again, a classification of the occupancy group, So it'd be like an R3, for example. And if you still want to use, for example, wood framing, light frame wood, that would be probably a 5B structure as an R3 per the IBC and how you're going to build it. The big trick is once I go to the IBC, generally, I'm going to expect that you got the sprinkler system in the building, whereas the IRC does give me provisions if you choose not to put the sprinkler system in the building. So some big consequences there. But the point being, I've given you engineering in a cookbook approach, which allows you to tell you how to build the building without bringing in necessarily an architect or an engineer. But whenever I exceed what is the engineering that was included in the book, I have to go to an appropriate individual who's going to give me the design. And by law, your jurisdiction, i.e. the state you're located in, is going to say, here's the group of people that are allowed to do that. And they're what are considered registered design professionals, your engineers or your architects. And so they must provide the design associated with it, because we don't expect that the builder, contractor, homeowner, tenant would have that degree of knowledge to know what are the best options and how to make it sure it's structurally sound. Concepts on that? Anybody? Is everybody on board? Any questions? Sure. Okay, are you asking about the grade plane, or are you asking about? Yes. Look. Okay. Okay, good. I want to make sure I was answering the right thing. So what we did is we did this calculation of where our average of the ground all the way around it is. And so that's called the grade plane. From that point, we go up to our first floor. So the floor above the floor that's in ground or partly in ground. So the first floor line, we're measuring from there to my grade plane. And if that is 6 feet or more, that is considered, then the lower floor is going to be considered a story above grade plane. And I got to count it. Yeah, it says from the floor level. So most people take it from your finished floor line down. Yeah. Yeah, it's not real clear. You've hit on that. You're right on, Chris. Now there's one other measurement that could also trigger that basement being a story above grade plane. And this one says from the first floor, the floor above the floor in question, I go down until I hit finished ground. A point or more of finished ground. It doesn't say the grade plane here. It's talking about finished ground. And it says if you are 12 feet or more, then that is going to be considered a story above grade plane. So let's take a real steep hillside, and I have what is partly in the ground, or maybe it is got ground up to it, but yet there's a point where I go from the first floor and I measure down the side of the building, and we've got finished ground 12 feet or lower in terms of that's where my exposed wall is for that basement area. Then they're going to say that basement gets considered a story above ground too. So those were the two conditions which dictate that it's going to be a story above grade plane. Now, the only reason I'm going through this, first off, for those going for the certifications, this is in your definition, and we got to know what the scope limits are of the IRC. So when it's not appropriate to even use the IRC. The other aspect is the IRC assumes that we're not forcing you to use the architect or the engineer, because I've given you how to build it. whenever you go to a condition where you're not using it for your construction, or you are going to have to go to someplace else because you're out of the criteria. I'm in a high wind area. I've got greater seismic conditions than what this covers, things like that, or I'm using different materials that aren't covered in the IRC, then I would have to go and get the registered design professional. And they're going to tell me what to do. Now, we traditionally run into, and I'm going to go over that in a few minutes, conditions foundation wise, footing wise, where maybe my soil profile doesn't meet that 1,500 pounds per square foot. So that means my footings, I can't use the ones that are in the IRC. Well, that means I need to get an engineer or an architect or design professional, in other words, to design that. But once they've done that, framing the floor, framing the roof, framing the walls, if I'm still within the scope of the IRC, I could use that part. The only parts I couldn't use were the footings because the soil wouldn't accommodate those types of footings. So it doesn't throw me to having necessarily the whole building engineered or designed, but it may include parts of the building. Thoughts, questions? Everybody with me? Okay, I'm leaving it to y'all to interrupt me if you're not, because I'm going to make that assumption that you are.